First question, this is just a simple Horner's rule. Yeah. Using Horner's rule, we have it. Yeah, most of you got this one. Yeah, but I remember 1 or 2 students missed this one. Yeah. It should be true, Horner's rule. Okay, yeah. But at least 1 student missed this one. Yeah. Based on my impression, yeah. Number 2, yes, remember the algorithms. Remember first, iterative algorithm. Bottom up, iterative, for loop. Second, dynamic programming, top down, but still, if we store the computed Fibonacci numbers in an array, remember known array, we store also linear, bigger or than, and in place. Yeah. Just a minute. Dynamic programming, because we need to use recursion. When we talk about in place, if we use recursion, we should be careful. Yes. Yeah, because recursion, we use stack. The stack could be deep. How can you say you use constant bounded extra memory space? So the recursion type in place, we can call weak type in place, weak in place. And the non-recursion, our iterative in place version, we can call strong in place. Completely without too much extra memory space. Recursion, the stack issue we need to consider. So it may not be exactly the input, but we have iterative version. So answer yes is okay. Yeah, no problem. Yeah. Number 3, GCD algorithm, when we derive size reduction. Remember, in class, in our notes, we use the division algorithm. So here we use division algorithm. And when we use that, we drop the quotient part. That quotient part, when we use division algorithm, multiple of n can be dropped. So we will reduce the GCD to R and N. Yeah, so that's the D. Yeah, only one or 2 students missed this one. Number 4, the answer is here. Yeah, answer is A, not B. This one missed a lot. Yeah. Similar to our homework questions. Yeah. Homework question, that question, 1/2 of you missed this one. But this question, more than 1/2, based on my impression, more than 1/2 missed this one. Yeah. All right. We use our formula. Remember, this formula should be used. Okay, we need to use this formula. When we use that, A, although we need to do a lot of computation, we can convert it to exponent, log base 2 of 3, exponent. All right. B, exponent, 3 of 4. Okay. Yeah. Now you only need to compare these 2 numbers. log base 2 of 3, and then log base 3 of 4. All right. Yeah, let me repeat. How do you derive that? Let me repeat one. In class, I did part of it. Yeah, I did part of it. Yeah, how much I did? I'm pretty close. All right, 3, by this A formula, we can write 2 log base 2 of 3. Okay, yeah. Use this formula. N equals 3, A equals 2. Yeah, so we have that first. Then we raise 3 to log base 2 of n, 2 log base 2 of 3, parenthesis, log base 2 of n. All right? Yeah. Multiply 2 number at the exponent multiply together. All right, yeah. And switching the order. Yeah, not necessarily switching the order. How about we write this way? By logarithm property, all right? This is a constant we write as the exponent of n, because by the logarithm property, we can do that. Constant as the exponent, that's the logarithm property, all right? This whole thing treated as one number, base 2, cancellation by that formula, all right? So something like after simplification, yeah, after simplification and log base 2 of 3. Yeah. That's the procedure you derive this. Now you compare log base 3 of 2 of log base 2 of 3, base 3 of 4. You can use calculator. All right, you can use the online calculator. Yeah, all right. So this one approximately 1.5 something, 1.5 something. That one approximately equal to 1.2 something. So you know the first one greater than the last one, the second one. Yeah. 1.5 something, 1.2 something. Yeah. Yeah. So that's question number 4. Yeah. Number 5, actually this is a pretty easy question, but so many of you missed this one. Yeah, at least 1/2 of you missed. Yeah, more than 1/2. Answer is C. Answer is C. You just find A and B. Okay, all right. A, you need to find a median of 3-element array. Find a median. In order to find a median, actually you have to sort it. The same as you sort the array. Only true for 3-element array. Median, you know, one in the middle. So you must also know one smaller than median, one greater than median. That's the sorting, all right? And also when we sort with we need 3 comparisons. They all equal to 3 comparisons. Okay? Yeah. A, B, they both equal to 3. That's simple. So many of you give me A in that way because people usually, based on their intuition, find a median should be using smaller number of comparisons than sorting. In general, it is correct. In general, it is correct. But when n equals 3, the answer is different. 3 is special. 3, that n number too small, so you need to do the same amount of work. Same amount of work. 3 comparisons. Yeah, so that's the reason I give you this question. Okay, 3-element array. Yeah. Not the general case. General case, if you tell me A less than B, it's correct. Correct in general. That's fine. We can exclude the special case n equals to 3. All right. Yeah, number 6. Answer is C. Quite a lot, quite some. Yeah, I didn't count, but quite some. Yeah, quite some students missed this question. Yeah. Actually, let me explain. When we do the linear search, you know the steps. We do linear search. We go through array from the beginning to end. Right? Remember, when you apply linear search algorithm on an array, the computer does not have eyes. Okay? The computer is blind. The computer is blind. All right? So you give an input array that is already in order, but computer does not know it. Right? How do you make the computer know the data is in order? Right? But if the computer does not know the input is in order, it doesn't help. So still apply linear search from beginning to end. Okay? No difference. The computer won't jump to binary search to do faster efficiency. No. The computer does not know your data is in order. Your program, the computer execute based on your program. But your program is a linear search. Okay? No matter it is ordered, unordered, same way from beginning to end. In that way, the average case efficiency the same. Yeah, the efficiency, but here, we just look at the average case. The same. Yeah. Yeah. So that's, many students pick A. Yeah. Yeah. We have several cases like this one. The computer does not know your data. Yeah. Only based on the algorithm, ordered, unordered, the internal steps, mechanism will cause the difference. Then you can take it. For example, insertion sort. For insertion sort, when the data is ordered, then it stops quickly. All right? Yeah. So the algorithm itself stops quickly. That's different. Other than that, if you expect using our human intelligence to do something different, you cannot expect that. Human intelligence cannot be involved in algorithm execution just based on your program. Okay? Yeah. All right. Next one. Yeah, next one should be easy one. I talk about that in class. Average case. Overall efficiency, when you see overall, it must be average. I said best case cannot be used, worst case cannot be used. Overall, right? We need to consider factoring all the possible cases. That's the average case. Yeah, Easy questions. Yeah. Some students still miss this one. Yeah. Yeah, number 8, I also talk about in class. Remember? Yeah. When I explain what's the meaning of sufficiently large, I use similar example. I use this example. Yeah. Yeah. I even use some formula you can consider. n minus 10, for example, to the third power, then when n greater than 10, it's sufficiently large. Okay? Yeah. 10 or 10 is that line. You know? Yeah. n0, that line, 10. All right. Then if you put a huge number, okay? Yeah. How about this? 1 billion. How about this? 1 billion. When you use this example, when n equals 1 million, it's not sufficiently large, right? Yeah. Here, 100,000. I put a 1 billion here. That n0 line is 1 billion. Only when you pass 1 billion line, it is sufficiently large. But it's not if you consider 100,000, 1 million, 10 million, 100 million, not sufficiently large. That's the concept of the sufficiently large. Okay? So I just use that understanding. Yeah. Many of you missed this one. Yeah. So answer is 2. Okay. Number 10, another one. Several missed this one. Yeah, probably less than half. Yeah, but more than one. Answer is D. I spent a lot of time in class explain why factorize a large integer number as a product of primes. Prime factorization is so hard. Remember, in class, I spent at least 10 minutes on some example. What's that? In encryption, there is a famous encryption. Is that RSA? Yeah. Yeah. 3 professors' initial of their names, RSA. Yeah, probably that. Yeah, R is correct. Yeah, SAS. Yeah, but let's just call RSA that encryption method. They are mathematicians, so they use the number theory theorem. There is a famous number theory theorem. So they use that. So they develop some algorithm. Based on that method, they can do encryption very fast. Okay? Product of 2 big primes multiplied together, then based on that special algorithm, if you know those 2 big primes, then by that algorithm you can do decryption fast. All right. But the problem is if you do not know those 2 big primes, it will be very hard. All right. But in order to find those 2 primes, given a big number as a product of 2 big primes, the factorization extremely slow. Extremely slow. Okay? Based on that nature. Oh, one student. Yeah. Trying to join us. Yeah, Fuke. All right. Yeah. Fuke. Yeah. So, yeah. All right. Then it is extremely slow. All right. Yeah, even for use supercomputer years, you cannot break it. Even if you use supercomputer, try to do prime factorization on a big number with thousands of digits. Think about thousands of digits to do prime factorization. How can you do that in a fast way? Yeah, at least in years, many years. All right. I even talk about a news long time ago, some institute, agency, they give a prize. Who can get the largest prime in the world? 100,000 prize, $100,000 prize. And some UCLA, yeah, some UCLA, they had a team, they won the prize. Yeah. So that story just tells you how hard it is to do prime factorization. Okay? Yeah. With that, you can see first three, A, B, C, much easier. Right? A, B, C, much easier. Okay? A, we need a big O of n. B, we need a big O of n log n. C, also big O of n. That's pretty easy, but prime factorization, extremely hard. Okay? Extremely hard. All right, that's the story behind this question, number 10. Here you can see so many questions based on our notes, based on my explanations in class. Yeah, but still so many students miss all these things. Yeah, because I noticed actually the attendance not very good. Sometimes some students doing at the Zoom side, so I feel that may not be as good as in the classroom. In the classroom, in the classroom still some students look at the laptops, still not good. Distraction, at least distraction. Okay, so you need to really follow my lecture. I talk about so many things. You really need to follow my lecture content. Yeah. At least you have some impression. Yeah. Otherwise, when you see these questions, it's like something completely new to you, right? Something you never saw this before. Prime factorization, I never saw prime factorization. Right? But we talk about GCD. There are two methods we can calculate GCD. One middle school method based on prime factorization. Another Euclid algorithm, right? So then we compare which one is better. The middle school way, not good because this problem is so hard to solve, right? So that's what we learn in class. But it looks like many of you, this is completely new. I haven't seen this any time before. Yeah, that's why you just pick some random, right? Yeah. So that's something, yeah. The main reason you miss so many questions. Okay? Yeah. Number 11, still 2 or 3. Miss this one. Okay? Yeah. Tower of Hanoi, we know the solution, remember 2n minus 1, right? Yeah. In order to solve this problem with n disks, we need to move disk 2n minus 1. We solve a recurrence relation. This is exponential number, right? And Fibonacci number, big O of n. Which one much slower, right? Exponential algorithm much slower than that polynomial linear algorithm. Yep, so easy. Yep. Still, at least 2 or 3 missed this question. Okay? Yeah. So you can see, yeah. Although it's a short semester, very short, less than 2 months, but we cover a lot of material. You have to follow all the way, right? All along with the class. Otherwise, so much content. How can you memorize things, right? Yeah. Yeah. Yeah, but now it is near the final. You can see all those questions based on some points in the notes in our content. Yeah, nothing is new, brand new. Yeah. Number 12, still at least 2 or 3 students miss this one. We practice in homework. I emphasize, yeah, still students based on their intuition. When you see this number so small, you feel the whole expression should be small, but it's not. Remember, this is a power function, n to the dth power, but d greater than 0. Okay? D greater than 0. That is the log function, although you see n to the 10th, but that is still log function, right? 10 we can bring down to the front as the constant coefficient. Log n and a power function n to the dth power. We use L'Hopital's rule. We know that limit is 0. By L'Hopital's rule, equals 0. We did that in class. Yeah. So don't buy your intuition. Intuition you feel, long run. Sorry. Oh, which following is fast? Oh, sorry. Probably I did wrong. I did opposite. Sorry. Yeah. For you, I will give you points back. If you, the other way around, sorry. Faster should be this one. Okay, yeah. I think I should give you, some of you, points back. Yeah, you just check. All right? Wrong, right? Yeah. Oh, yeah, I'll give you 4 points back. Yeah, so if you, otherwise, if you got the wrong way, you just take it. All right? I do not take points off, okay? I do not take 4 points off, okay? Yeah. So if I got it wrong, I give you 4 points back, okay? Yeah. Yeah, because in my mind, which faster, slower, yeah. So, yeah. For other students, I just double check. Yeah, double check. Yeah. All right, long run, it's A, not B. All right, it's A, not B. Yeah. So you get 4 points back. Yeah. X. Oh, yeah. Sorry. Number 13, B. Yeah. Remember in class, I give you a hint. X equals log base 10 of m. So here you have x squared. Thus you have x over log base 10x. All right. Here you have log x. Here root x. So you will see B is the lowest order of, has the lowest order of growth. Yeah. Log has lower growth order than any power function. All other functions basically power function. Okay? Divided by, but you still, after the numerator, for C, numerator conquer, numerator just take small part to conquer that log. Yeah. So you can control that log easily. You have some positive exponent left, right? You can beat that B log. Yeah. For T, yes, based on some special questions we did a few times in class, but one or two students missed this one. At least one or two students, yeah. I saw at least one, okay? Because we know we can do that 1 plus x to the 5th. We can consider this special example. To calculate this special polynomial, we need 1 addition and 3 multiplications. All right, yeah. Repeated squaring, 3 multiplications. Yeah. Number 15, we just did one similar question in homework assignment number 1, and I mentioned that before the test. Yeah. In that question, we have x2, we let y be x squared. Yeah. X squared. Yeah. This one, we let y be, yeah, this is old one, y be x to the 4th, but you need 2 multiplications to find y. 2, all right? You need 2 calculating y. After that, you apply Horner's rule with y as the variable, new variable, all right, yeah? So 6 more, 6 plus 2, 8. Yeah. Still, several students give me 7. Yeah. 7, not 8. Yeah. In our homework, it's 7, but I changed the number. Yeah. Still, yeah. So you can see you missed so many easy questions, easy points. Yeah. Yeah. That's all 15 questions. See? See? Yeah. Based on my impression, the average is pretty low. Okay? Average of this part A, even part A, pretty low. Yeah. Around 50%. Okay. The average of this one around, yeah, because so many students below 50%. Yeah. A few students above, yeah, but average around 50%. Part A, yeah. But you try your best. Yeah, for those students relatively low, you try your best. So you should have a good chance to pass this class. The thing is, if you can do well in 2 programming projects, just make it work, produce correct answers, you can get full credit. Programming project, then it will bring up your average a lot, quite a lot. Okay? Yeah, even these assignments relatively low, still you should have a good chance. Okay? Do the best you can. Yeah. Yeah. So you should, passing this class not that hard. All right? Not that hard. Yeah. But don't miss too many. Yeah, so that's why control the damage. Do not miss too many. Yeah. That's part A. Part B. Part B, yeah. The first is like a free question, easy free question. Yeah, yeah, it's okay. Yeah, but still, you missed a lot remaining. So question number 2 also should be easy. X6 is the median, so you can exclude X6 immediately, right? Because you do not need to consider. So we, based on our elimination method, X6 can be eliminated immediately. After that, just a 10 element array. So you can, when you start with some, 10 element array. And the top 3. Yeah. Top 3 in 10 element array, eliminate 7, right? Yeah, eliminate 7, so comparison 7. No. Our 185, that homework question, so you use that example, but you only need to do one little thing, eliminate that median first. That's simple. Yeah. Simple modification. Yeah. Yeah. You need to connect. Yeah. So all the knowledge you learn is useful for you. Yeah. 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 This one. Yeah. Calculating the correct answer probably a little hard. Yeah. Yeah. Because the expression is so long. Yeah, but if you write the correct expression, I give you full credit. Yeah, I do not require you give me the final correct answer. If the expression is correct, then you get full credit. Yeah, so based on my hint, 1 times 1, 2 times 2 to the first, 3 times 2 squared, and so on. All right, yeah. And before the bottom level, 8, right? 8 times 2 to the 7th power. Then the last one, 9 times 112. Yeah, because 2 to the 8th minus 1 less than or equal to the largest power of 2 minus 1 less than 367. So that one. So then this is 255. So you use 367 minus 255 equals 112. Yeah. Divided by 367. If you give me this 112, I'll give you 2 points. Okay? Then the remaining 2 points, you need to write this expression. Well, you do not have to give me the final answer. That's enough. I assume if you use computer, you can find the final answer. All right? So, yeah. Just matter of typing. Yeah. So that's not a big deal. Yeah. Okay? We do not rely on, you use the mental computation to do it. Yeah, not necessary. Yeah. All right. Yeah, but this one, yeah, so you missed a lot. Yeah. Yeah. Just write this expression. Yeah. This one, yes, yeah. This one answer is 4. Yes. This one probably the best you did. Yeah. The best you did is this question. Yeah. 2 groups. Yeah. Top group, with greater elements, 3 elements greater than their corresponding 3 other elements. So the maximum from the top group, minimum from the bottom group, 2 maximum comparison, 2 minimum, yeah. One student use some formula, that's okay. Yeah, formula. Yeah. Yeah. Number 4. Number 5. Yeah, this one I give you a hint, but most of you didn't get it. Even I give you, I think it's a pretty strong hint, but still, to connect the last connection may not be that easy. Yeah, so this one. Yeah, so for that reason, you miss this one the most. All right, yeah. So let us draw in this way, okay? Yeah. We know the selected element should not be among top 2 and should not be in the bottom 1, okay? Yeah. In order to select this element, you need to make sure at least 2 elements greater than this one. Then it cannot be top 2. At least 2 greater than this one, that one. At least 1 less than this one, so it cannot be the minimum. All right? So then, based on that view, you just consider 4-element group, right? Yeah? You select a 4-element group. From the original 10-element group. Yeah? Arbitrary 4 elements from 10-element group. And you only need to find the second smallest element. Second smallest element. If you can find second smallest element, then you make sure one element less, at least one element less than this element. At least 2 elements greater than that element. Satisfy the requirement. That's the view. Okay? 4-element group. The reason we want a smallest possible group, we can use fewer number of comparisons. The smaller the group, the fewer the number of comparisons. Yeah, so that's why we make the minimum group. Okay? Yeah. Then, the second smallest. All right, now here, let's consider x1, x2, x3, x4. We want to find the second smallest elements among 4 elements. Okay? Yeah. So let us do comparisons. Comparisons. x1, x2 comparison. Let us assume x1 is the winner. Okay? Winner means smaller. How about that? Winner means smaller. Okay? Yeah. And x3, x4, we can assume x3 is the winner. Yeah? Winner means smaller. Okay? All right. Then another comparison, 2 winners. Let us assume x1 is the final winner. Then after these 3 comparisons, 1, 2, 3 comparisons, x1 is the winner. Okay? Yeah. Here we use 3 comparisons. Comparison 1, comparison 2, comparison 3. All right? We use 3 comparisons. Okay. After that, x1 is the smallest, but we want the second smallest, not the smallest. So we should look at the remaining 3, not x1. x1 is excluded. All right. Among the remaining 3, we want the largest. How about that? Remaining 3, the largest one is the second smallest. Okay. Remaining 3, all right, x2, x3, x4, and we know x3 beats x4, right? We already know x3 beats x4. x4 cannot be the remaining smallest. Yeah, it is greater than x3, so x3 beats it. So the remaining smallest among x2 and x3, we do another comparison. Let's say x2, so that is the 4 comparison number 4, right? So the final to get an answer, second smallest in 4-element array, 1, 2, 3, 4 comparisons. So the answer is 4. The answer is 4. Yeah. That's the work you need to do. That's the work you need to do. Second smallest. Second smallest. First, you need to get the first smallest. Exclude it. Remaining smallest. Yeah. Second smallest. 4-element array. A small array, so it should not be too hard for you, right? It is a small array. It should not be too hard for you. Yeah. And one or two, a few students, they sort 4-element array. Yeah, I saw a few students, they sort to, if you sort, you need 5 comparisons. So you do not get the best answer. You do one more than necessary, but you can get partial credit. Partial credit, if you 5, you can get 2 points, at least 2 points. Yeah. Number 6, answer is 9. Yeah. I give the hint in class, yeah, 10 minus 1. Yeah. If we do not factor in x3 in place, that's 10, right? That's 10. Yeah. Reverse order, yeah, descending order, yeah. But x3 is in place, so you have to move x3 to a different location. Then you have to use one fewer inversion. You can get that example easily. Yeah. So that's the reason I ask you play around to see if you can get that kind of example. Yeah. Answer is you can get that. Yeah. So answer is 9 here. Yeah. This one, everyone got this one, okay? Yeah, so 565, yeah. I mean, that 2021 minus 1456, yeah? Good, yeah, that's an easy question for you. Just like the question number 1 and this one, you did the best, yeah. The whole class, yeah. Number 8, yeah. We know we sort the array, yeah. 5 minus 1, right? Because sort 4-element array, we need 5 comparisons, okay? Yeah. So answer is 4, 5 minus 1. So the given condition already can save you 1 comparison. Now, then you just do the remaining. You need 4 more comparisons. How to sort 4-element array by 5 comparison? I don't know if you know how to do it or not. All right. Here, because some of you even. Yeah, I hope after I finish explaining part B, we can take a break. Yeah, a few more minutes. Yeah. Some students, when they work on this one, it is very messy. Yeah. Although they get correct answer, but the work is very messy. Yeah. Here, I give you one simple way to do it, very easy. You can get that. All right. First, 4-element array, right? Let us take the first 3 elements and sort it. How easy it is. Okay? X1, X2, X3, and sort this array. How easy it is. Okay? 3 comparisons, right? Yeah. 3 comparisons, we get it sorted. That's our starting point. That's our starting point. Okay? All right. Then, the fourth one, X4, look at that. The X4, we want to insert X4 somewhere in the right place, right? Insertion operation, right? Insertion operation. But here, when we do insertion operation, we have freedom to choose which one to do the comparison. Binary search. Binary search way. When you do comparison, you compare X4 and X2, do binary search way. Then you only need 2 more comparisons. Okay? Compare X4 and X2. If it is greater than X2, then compare with X3. Right? If it's less than X2, compare it with X1. You get it sorted. See? So 2 more comparison. You can get X4 inserted in the right place. So the answer, 2 plus 3 equals 5. That's so simple. Yeah, not very messy. Yeah. If you use, yeah, because many students, juggling around, X, Y, and keep track of a lot of information, very messy. Very messy. You get lost. Okay? But if you use this way, so neat. So neat. Okay? Yeah. This is probably the best way. Yeah. There are many ways, but this one probably the simplest to get the right answer. Yeah. Question number 8. Question number 9. Number 10. Yeah. Because we're close at the break time, I couldn't finish these 2. So let me continue these 2 questions after we come back at 2:30. Yeah. Because we need at least 10 to 15 minutes to complete the last 2 questions. Yeah. All right. Yeah. Take a break. Yeah.